The following video was recorded before the merger of Reliam, Stratalux, and G2 into one company. We are now Mission. Let's achieve yours.
All right, welcome everyone. I think we're ready to get started. Thank you for joining today. This is the fifth part in our five-part series on the Well-Architected Framework. Really excited to talk about this pillar, the performance efficiency pillar. So let's get started. First, an introduction to me. I'm your presenter. I'm Jonathan LaCour. I'm the CTO here at Reliam. I'm a technologist, a cloud strategist. I've been using or building on cloud infrastructure since the very early days of AWS. And obviously also I am a programmer and a bourbon junkie. So that is another little fun fact. Okay, and let's talk about Reliam. We are actually an AWS certified consulting and managed service provider. We help companies make the move to AWS and work with them to optimize their workloads and actually do managed services as well. We're a launch partner for the AWS Well-Architected Review program, and we have engaged directly with AWS in formal training programs to qualify our engineers to deliver well-architected reviews. So we're experts in the well-architected framework. And in addition, we've recently merged together with two other AWS managed service providers, Stratalux and G2 Tech Group. And now we boast over 80 certifications across over 100 people here at Reliam from AWS. So that's a little bit about us. So throughout the presentation today, I'm going to put in some questions and polls for the audience to kind of get to know you a little bit. These are completely anonymous, so feel free to be as honest as you want, and we'll share the results with everybody as we go along. So the first question here is, how is your company currently using AWS, if at all? I find this to be a really interesting kind of question to ask as we've gone through the series, because we found there's quite a lot of people who attend these webinars who are learning about AWS, right? Who are just, kind of getting started. Generally, we see a good mix. So I see the answers starting to flow in now. All right. Good participation so far. I'll give a couple more seconds here for everybody to vote. All right. Let's go ahead and take a look at the results here. Interesting. Well, look at that. Over 40% of you are already using AWS in production, with nearly 20% using for test and experimental. 13% are taking kind of a hybrid approach, using some AWS and something on-prem. 10% of you about are in the process of migrating, which is great news. We're always here to help if anyone needs help migrating. And 20% of you are still, kind of looking into AWS. So welcome to those of you who are wanting to learn more. Great opportunity today to do so. So let's go on and talk a little bit about our agenda for the day. So first, we're going to give you kind of a lightweight introduction to what well-architected actually is and the well-architected review program. And then we'll dive right into the performance efficiency pillar. We'll start with the design principles of the pillar itself, and then we'll talk about best practices around the four main focus areas, which are selection, review, monitoring, and trade-offs. And we're going to definitely have some time for Q&A at the end. We do have a lot of content to cover. So if you have questions, feel free to start tossing them in the questions and answers section of the webinar. We actually have one of our senior platform engineers, Brian Young, here. He'll be monitoring the questions and doing his best to provide some answers as we go. And at the end, I'll kind of take a look at the questions that have been submitted and provide some kind of on-air answers to some of those questions. In addition, I'll point out that we do have a handout attached as well, which talks a little bit about how you can ask Reliam to actually provide a well-architected review for you. And we'll talk a little bit about that in a moment. So let's dive in and do a quick introduction to well-architected. It was introduced back in 2015 at the reInvent conference, and AWS's CTO, Werner Vogels, he announced a well-architected framework in the form of a series of white papers targeting 5 separate pillars, collecting best practices and guidance about how to architect properly for AWS, for the cloud. And AWS has continued to evolve the well-architected framework, and now I believe it's the most complete and thorough collection of best practices and guidance that are available for organizations that are going to the cloud. And the really interesting thing about it is that there's a lot of benefits to the well-architected program. So first, the principles help you move more quickly, right? And in my experience, that's the biggest demand on a operations team or a product org is go fast, go faster. and the best practices outlined in the well-architected framework can really help bolster your kind of speed and efficiency. It also helps surface risk and helps you address those risks before your apps are out in production. And as CTO, I frequently have to make big financially meaningful decisions, and the well-architected framework is really helpful because it helps you focus on rapid decision making by designing your applications and workloads to be very observable. And another common problem that I encounter a lot, and I'm sure a lot of you do, is benchmarking, right? Understanding, is my architecture and my procedures, my operations systems and practices, are they up to snuff? Are we doing things the right way? And these best practices are a great way to benchmark against those best practices, right? See how you're doing. And one interesting way to accelerate your path to a well-architected workload is to have a certified partner like Reliam perform what's called a well-architected review. This is when one of our solutions architects who's trained in the program will actually come on site and walk through your entire workload and understand across all 5 pillars of the well-architected framework how you're doing with the benchmarks. And we perform dozens of these for our customers, and at the end we deliver a report outlining the areas of improvement across the 5 pillars. And here you can see some of the output of our reviews. So this is the collected insight from the dozens of reviews we performed, and you can see that 96% of reviews that we perform surface critical issues in the security pillar, and 79% in the reliability pillar. So there's, regardless of how effective and good you have been and diligent you've been, there's always things to learn. So even if you think you're already well architected, that review is really valuable to benchmark. And the great thing about this is AWS wants people to be well architected because it helps ensure that they're happier customers. They're customers who are going to be successful and build future products on top of AWS. And so they've enticed basically people to go ahead and get well architected reviews from partners like Reliam by creating a program. And essentially it works like this. We deliver a free well architected review and a statement of work for 20 hours of work from our engineers who can help fix any issues that kind of come up and surface. And that costs $5,000, but AWS credits back $5,000 to you as part of your bill. So it's essentially free, and you get all of these great insights and reports, and you get to engage with us and learn a little bit about our capabilities. So it's really great. That's what the handout's about. Enough with that. Let's go into the performance efficiency pillar itself. So let's talk about the design principles first. So each of the pillars includes a set of design principles, and the 5 design principles for the performance efficiency pillar are to democratize advanced technologies, go global in minutes, use serverless architectures, experiment more often, and mechanical sympathy. So let's talk about the first one, which is democratizing advanced technologies. So I don't know about you, but at most companies that I've been at, it can be difficult to drive the adoption of advanced technologies for a number of reasons. But one of the biggest is there's a burden to deploying new things and managing those new things, right? So if you want to adopt a new NoSQL solution or machine learning platform, you have to install that platform, configure it, understand how to operate it, or tinker with anything. You have to basically go through this entire process of getting it in completely operational state. And IT organizations typically struggle with that, right? It's we've got other things to focus on that would be a distraction for us. Well, AWS really wants you to take advantage of their managed services that they have. So you can use the fully managed machine learning algorithms, and you can use AWS Elemental to do video transcoding, and all sorts of other advanced technology is available to you from AWS to consume as a service. And that democratizes those advanced technologies. That principle is, don't hesitate to adopt something new and to try something new, because that burden of managing it is now gone. It helps you move more quickly, improve the quality and performance of the products that you're delivering to your customers. So I'm just curious here, a quick poll. How well does your company adopt new technologies? Just kind of interesting to see, because my experience has been generally that companies are a little bit reticent to do so. So I'm seeing some answers flow in here. Very interesting insights. Okay. So it looks like, all right, I'm still seeing some votes flow in here. Very interesting. I like getting the sneak peek. It's kind of part of the perk of being the presenter. All right, great. Well, thank you all for your answers. Let's go ahead and take a look at the results. This is close to kind of my suspicions. About almost 40% of you are busy dealing with your existing systems and managing and operating those existing systems. And I think that's one of the things that AWS really helps with, right? Giving the capability to say, hey, try out these new services, all this advanced technology is available to you to just consume and to try in a very lightweight way. You only pay for what you use, and you don't have to worry about setting it up. So good, thank you for that. Let's move on to the next design principle, which is to go global in minutes. So for most businesses, we're finding that our user bases are increasingly global, right? Distributed around the world. And the performance efficiency pillar really wants you to have this capability to go global in minutes. And I think the key part of that is the in minutes side of things. If you want to be able to go global in minutes, you need to be able to take advantage of a cloud platform, right? Because you need to have a worldwide presence of regions and edge locations that you can take advantage of. And that's really all about accelerating delivery to your customer and meeting them where they are. So the next design principle is to use serverless architectures. I've actually been building software for a couple decades now, and to me, serverless is one of the biggest positive changes in how I think of architecting systems ever. And the ability to focus on code without having to worry about managing the execution environment is a pretty powerful abstraction. And managing servers can be a real burden. So Reliam, that's one of the core part of our business is we help organizations with that. We take that away from them if they don't want to deal with it. And that's an important and critical factor, right? Getting free from the management of servers, but you can also adopt serverless architectures, which we help people with all the time, to then really free yourself completely from managing servers. And it also can really enhance your ease of scaling. And we'll talk about that in a little bit. So I'm curious real quick, if anyone here is actually using serverless architectures yet. Lambda was only introduced a couple of years ago, 3-4 years ago, and I think I've seen quite a lot of traction. So I'm curious to see with the attendees here, how many of you are using serverless architectures? Great, thank you all for answering very quickly and getting a lot of engagement here. It's awesome to see the data flowing in. Great, okay. Let's go ahead and see the results now. All right, look at this. This actually backs up kind of what my suspicions were. Only a very small group of you is actually doing heavy amounts of serverless, with 20% of you starting, and another 20%, having some good traction so far. Over half of you haven't started yet. And I think if you are considering serverless architectures, this is one of those things that we've really become experts in, and deploying quite a lot of serverless workloads, helping customers manage them, and also doing a lot of Lambda at the edge to actually use serverless at where your customer is, right there at the edge, to deliver, kind of customized services to the customer. Very cool stuff. Great, well, thank you so much. Let's go on to the next design principle, which is all about experimentation. Experiment more often at the design principle. So as I said, I've been developing software for a couple decades and managing technical teams, specifically product teams, for a while. And in my experience, one of the most important ways to drive innovation on a product team is creativity and experimentation. And the cloud gives you kind of on-demand IT resources, and it's fully automatable, and it gives your team the power to experiment and create more often. And with regular experimentation, you get improvements to performance, security, quality. You create new features that you hadn't anticipated the ability to create. And I think our technical teams are an underutilized creative group. And AWS agrees with me here. So experimenting more often can really drive capability. So the next one is called mechanical sympathy. And this is kind of a funky term. It took me a second to kind of understand what it means. And the notion here is that you should align your technology approach and choices with your goals. And AWS offers this massive breadth of services to choose from, and it's critical to really understand what those services are and which ones you should use that are best matched with your goals. A lot of times I hear people on technical teams making choices around compute, network, or database, or storage based upon like a preferred vendor list. I think that's a mistake, right? I understand where it comes from, but a lot of times you'll end up with this mismatch between what you're trying to accomplish and the technology that you're using to enable your teams. And AWS really wants to drive home this notion of mechanical sympathy. Use the right tool for the job. Don't worry too much about having a large breadth of tools. That's a value. That's a good thing. Yes, there is a learning curve there, but once you grasp all of the power that's available to you from the services that AWS provides, you can really create much better, faster, more efficient solutions. So that's the last design principle. Now we're going to dive into the focus areas. And there are only 4 in this pillar, but they're pretty in-depth. So got a lot of ground to cover here. The 4 are selection, review, monitoring, and trade-offs. So the first area is selection, which is all about choosing the right technology to meet your goals, right? So this is part of that mechanical sympathy we talked about. AWS provides dozens of services with hundreds of features. On top of that, you have configuration, options, and one size fits all just does not apply to well-architected workloads. And that means you're gonna have to consider the entire breadth of the catalog, choosing the best approaches, services, and configurations that meet the needs of your particular workloads. AWS provides some really great resources to help you with this. One of my favorites is their reference architecture guides, and those are super helpful, and they have them for all sorts of different solutions and industry types and verticals and workload types. But AWS also highly recommends working with an AWS partner like Reliam. We've been architecting and managing workloads for customers for years on top of AWS. And so we've got a lot of expertise at helping you say, okay, this is what my workload is doing. Which services do I need to leverage, and how do I leverage them to get there? So we can help you choose an appropriate architecture. Most systems actually require a multifaceted approach. And that means that you need to combine several architectural patterns together to create a high-performing system. So AWS outlines 4 key categories of resources to talk about during the selection phase: compute, storage, database, and network. So let's start with compute. And in AWS, there is actually 3 types of compute to consider: instances, containers, and functions. And your goal in the selection process is to choose that right blend of the compute types that give you consistent performance regardless of demand, right? So as demand goes up and down, you get consistent performance. Instances are the most familiar and common option. Containers are, much more popular these days than they have been in the past, and they're really helpful for utilization and resource packing, makes deployment a little bit simpler. And functions are sort of the new kid on the block, as we talked about earlier, and they're extremely useful for more event-driven architectures and highly parallelizable components. So let's go into each of these, starting with instances. So when we're talking about instances, we're talking about EC2, virtual servers, right? And they come in a variety of families and sizes. You have options for things like GPUs, FPGAs, burstable instance families, and more. And so you really need to consider compute, memory, and storage on those instance types and families, and how that will impact your overall system performance. And you need to also take into account the cost impact of your choices. While it would be nice for us to run every single thing on the most expensive high-end instance types, it doesn't make sense for performance efficiency, right? That's the efficiency part of it. AWS actually provides burstable instance families. These are really useful and helpful for workloads that maybe require more of a moderate level of CPU performance, generally speaking, with the occasional need to burst up to significantly higher performance. They're great for general purpose workloads like web servers or developer environments. And when they're in a steady state, you kind of accumulate CPU credit, and then you can consume those as demand rises. That's a useful best practice. AWS also supports, as I mentioned earlier, graphics processing units, GPUs, and those can be leveraged by platforms like CUDA to handle highly parallel tasks like 3D rendering, video compression, and so on. And in many cases, GPU hardware acceleration can improve your performance and reduce your cost, in spite of the fact that there is a cost associated with those GPUs. FPGAs, which is field programmable gate arrays, those are custom hardware accelerated execution. So you can actually build algorithms in like C or Verilog, VHDL, Go, and then you can essentially execute those with FPGAs to get accelerated performance. This is another really useful best practice. A lot of people aren't aware that that exists on AWS. And finally, AWS gives you access to some kind of advanced computing features available in a lot of modern CPUs, like Turbo Boost, coprocessors for cryptography, AVX extensions. And it's really important to know what's available to you and to try to take advantage of it if it fits your workload. So there's a lot to consider when selecting instance types. And AWS really advises you to take a data-driven approach. So when you're going through the process of making this decision, collect a lot of information. What is your workload trying to do? Are there highly parallelizable tasks? Would a GPU or an FPGA help you? collecting that data, and then you can kind of guide yourself through the process of making those decisions. So the next segment of compute to talk about is containers. And instances provide virtualization, kind of a whole machine, whole system at the server level, and containers are at the operating system level, right? And you can deploy an application in resource isolation inside of an operating system. And Amazon provides several container-centric services. The first that was introduced was ECS, or Amazon EC2 Container Service. It's a managed container service that provides automatic execution and management of containers on a cluster of EC2 instances. It's well integrated with the rest of AWS, including auto-scaling, and it provides you with metrics-based scaling of your services by scaling the number of containers and the backing EC2 instances up and down based on demand. And ECS is also integrated with ELB, Elastic Load Balancing, so that you can distribute load across the services in your container fleet dynamically. In addition to ECS, AWS has launched the Elastic Kubernetes Service, or EKS, which provides a fully managed Kubernetes environment. For those of you who have tinkered with Kubernetes, it is not easy to manage. There's a lot of effort and work that goes into it. We actually provide Kubernetes support for a lot of our customers, and EKS is actually a really great option because it gives you a fully managed EKS environment. You don't have to worry about it, you kind of just consume it as a service. And you can take that even further by using AWS Fargate, which is a kind of a launch option for both ECS and EKS that even further reduces your need to worry about managing the fleet, worrying about the EC2 instances. It's just fully automatic, right? So this is kind of the next step in containers from AWS. So again, use data to drive your decisions when you're making your choices around containerization. And finally, let's talk about functions. So instances of containers give you full control over the execution environment. And in many ways, you know, it's kind of stepping down the stack, or I guess up the stack, right? So with instances, you're getting full control over the operating system, all of the, you know, libraries and systems that are installed inside that operating system, and then you deploy your application in there. With containers, you get one layer up from that where you're packaging things into a container at the operating system level and controlling that execution environment a little bit in a more tight way, a little bit simpler than managing an instance. With functions, AWS completely abstracts that away. And all you have to worry about is your application code. So you execute code without running or managing servers or containers. And Lambda pioneered functions as a service when it was introduced back in 2014, completely changed the way we think about compute, in my opinion. And the really great thing here is that you can trigger Lambda functions by events from other services. You can call them directly with direct function execution. And one of the most powerful abstractions, in my view, is actually exposing Lambda functions as web services using the Amazon API gateway. So if you're familiar with building out microservices, this is a super powerful abstraction. And this is sort of my go-to method for building out microservices these days. You can define, create, publish, and monitor a secure API at massive scale. API Gateway handles all of the HTTP kind of scaling layer, and it has all of the ability for doing things like API keys and throttling and all of the mapping down to the Lambda functions themselves. And the great thing about Lambda is you can execute functions in massive parallel. So if you're auto-scaling around an instance or a container, you're going to need to scale up and out, right? So you're going to add more containers, you're going to add more EC2 instances, you're going to make bigger EC2 instances with more CPU cores. With Lambda, each function call is essentially running in its own little environment, and you're getting between one core and more cores depending on the size of memory allocation you give to the function. So that's a best practice. You configure the amount of memory a function will have access to, and that also gives you proportional CPU to go along with it. So, but you can call those functions as many times as you like in massive parallel. And this is a really great way to ease your scaling woes, right? You don't have to worry about metrics-driven auto-scaling, you know, ramping up servers up and down. You just call the function more times. It's pretty powerful abstraction. So before we move on from compute, let's touch a little bit on this elasticity concept, which is what I was just talking about with serverless. And elasticity is the ability to kind of align your resource supply with demand for those resources. Now, if you want a lot of detail on this, I highly recommend that you watch our webinar that we did last month on cost optimization, which has an entire section on elasticity and matching supply with demand. Again, I think the one take home from a performance efficiency perspective here is that instance and containers require provisioning time. You might have individual resource failures, and you have to build out automation and use auto scaling. You have to build a lot of monitoring to have metrics to base your auto scaling decisions on. And serverless architectures, they take away a lot of that pain. So it's definitely worth evaluating. And I was really glad to see in the earlier poll that a lot of you were already doing that. So speaking of polls, let's talk about what your company uses for compute. So we already know some of you are tinkering with serverless, but let's see, and please select one or more, right? So if you're just using instances, you can just check instances. If you're using containers as well, check that. If you're using functions, check that as well. My suspicion, and I'm seeing the votes here, is a lot of you will be using instances. All right, come on. I see a few of you still haven't voted. I'm going to give you a couple more seconds here. Oh, thanks. Here you go. You're starting to flow in now. Appreciate it. All right, I think that's good. All right, well, look at that. As I suspected, over 90% of you are using instances. 47% are using containers. Actually, that's a little bit lower than I expected, but 26% of you are using functions, which is a little higher based upon the earlier data. So very cool. I would encourage everyone to really explore both containers, especially with the Fargate launch option. I think that's a really interesting and intriguing approach to containers. And functions, obviously, I'm high on. All right, let's go on to the next section here. So we talked about compute selection. Now let's move into storage. And surprise, surprise, just like with compute, storage in AWS comes in many forms. It runs the gamut of block, object, and file with a variety of performance characteristics, options, configurations, and constraints. And selecting the right solution for your applications, it requires the same diligence that you used for compute, data-driven approach again, and potentially leveraging partners like Reliam to help you make those decisions. AWS recommends driving your selection process with kind of three main considerations. The first, characteristics. So each type of storage has characteristics for things like latency, throughput, shareability. Understand the different trade-offs there and make the right choices. Configuration options is the second. And optimizing your storage for your workload, you need to use the tunables that are available to you to make sure you're eking out the maximum amount of performance from your storage option. And finally, considering access patterns. What are the throughput requirements for your applications? Are you more concerned about storage cost or performance? Will you access the data with one client or multiple clients? That kind of information is really useful. So in the AWS Performance Efficiency White Paper, they actually include this great table here, which I think is a really nice perspective. So it outlines the four basic types of storage in AWS: block, file system, object, and archival. Archival is sort of a variant on object storage in my view, but it does have some different kind of attributes. So I think it's important that they kind of separate it out here. So for block storage, we're talking about EBS and the EC2 instance store. For file system, we're talking about EFS, Elastic File Store. And for object, we're talking about Amazon S3. And for archival, we're talking about Amazon Glacier. And you can see here, there's varying kind of latency, throughput, and sharing. We're going to talk about each of these, so I'm not going to dive into it too much here. So let's talk about block storage. Block storage is ideal for workloads where you have data accessed by a single instance, you have high IOPS requirements, and low latency requirements. If data needs to be accessed by multiple instances, you should probably look at EFS, which we'll talk about in the next section. For massively distributed systems, you might consider object, right? And when cost is a primary consideration, Glacier might actually be best. But block is really great because you have lots of different options along the EBS kind of spectrum, SSD backed and HDD backed. SSD obviously is more performance oriented, HDD is more cost oriented. And inside each of those, you have things like provisioned IOPS, so you can kind of get some more consistent guaranteed performance around IOPS. And you can actually even consider using RAID 0. So one of the patterns that we use for customers that have really high performance requirements is you'll get them, high provisioned IOPS, SSD-backed EBS volumes, and then you can RAID 0 them together to get even more performance. So that's a really great little best practice. So file storage. File storage is ideal for workloads where you have multiple instances that need to access. You have moderate to high IOPS requirements. You're not going to get as much performance out of a file store as you are out of block storage, but you can get pretty high IOPS out of EFS. If you have a workload that has low consistent latency requirements, maybe not the lowest, it's a good use case. And EFS is essentially exposed via NFS v4 to attach to EC2 instances, and it supports many simultaneous connected clients and provides kind of automatic scaling in the background, right? So it's a really nice service, useful for a lot of web application workloads where you may have an application that a lot of LAMP stack applications are actually really well hosted by putting the backing application on top of EFS and then attaching a fleet of web servers. So that's a use case there. So that's file. Archival storage is Amazon Glacier effectively, and it's good for use cases where cost is really your primary factor. You want to store something for a long period of time, you access it infrequently, you don't want to pay a lot of money, and you're not really worried about sharing the data around. Amazon Glacier actually has a great life cycling feature that allows you to move data in an automated fashion from S3 into Glacier and then through various life cycles, eventually even deleting it if you'd like. So let's talk a little bit about what you're using for storage. So similar to our poll question around compute, let's talk about storage here. I didn't include archival storage in here. I think it's less interesting as part of this. Interesting results so far. Give me another 10 seconds or so to answer. Seeing a good blend so far, which is actually encouraging. I'm always surprised when I find organizations that aren't using anything but block because object and file are so useful. All right, let's go ahead and see the results here. And I think this is actually, these are encouraging results to see from the group here. So it sounds like we have a pretty sophisticated audience here. Let's go ahead and stop the poll, Joshua. Thank you. So looking at the results here, 66% of you are using block storage, 56% are using file storage, and 46% using object storage. And that's great. And I think, for those of you who are only lightly dipping into object storage, I think that is an area of such intense interest for me personally. Amazon S3 was one of the very first services that AWS introduced, and it has grown to be so powerful and sophisticated with things like S3 Select and integrated with things like Amazon Athena. You can use it as a data lake now. We'll get into that in a little bit, but very, very powerful service. Highly recommended. Okay, so now let's talk about database. This is a area that is rife with just problems and kind of, we could do an entire webinar series just on databases, but let's talk a little bit about what AWS has to say in the performance efficiency pillar around it. So again, broad selection of services that you can use to help you meet your performance goals. And when you're evaluating database solutions, again, the data-driven approach is important. In on-prem environments, a lot of times we standardize on a single database platform just to reduce management overhead, right? It's, we have a preferred vendor, we're an Oracle shop, we're a Microsoft SQL Server shop, whatever it happens to be. AWS provides a bunch of different options, all as consumable, fully managed services. So that burden really goes away and you can start to get that mechanical sympathy and pick the database solution that's right for your workload. I believe, generally speaking, that most systems, holistic systems and applications, should be using more than one of these types of database. And there's 4 key factors that AWS wants to consider. Access patterns, as with storage, we talked about. The way you access the data in your database can have a big impact on performance. So pick a solution that fits your access patterns, or adapt your access patterns to maximize performance, right? That's a trade-off you can make. You need to consider things like indexing, partitioning, horizontal and vertical scaling. The next thing to consider is characteristics. So things like availability, consistency, latency, durability, the query capability and richness of the database. These are the important factors in your selection. If so, understand those requirements, familiarize yourself with the options that AWS provides you, and then pick the right one. In many cases, again, you're gonna have to have a combination, right, of relational, NoSQL, data warehousing to fully meet your goals. Configuration options. So Every database solution has a bunch of tunables to consider, and things like in-schema tuning, like indexing and things like that, partitioning, and then operational effort. How much work is it going to be for you to run this database, right? Can you consume it as a managed service? If so, you probably should. And armed with all of those requirements, let's now look into the 4 primary database technologies. OLTP, which is relational online transaction processing, non-relational, which is NoSQL, data warehousing and online analytical processing, or OLAP, and data indexing. So let's start with OLTP, which most people, when they think of this is relational databases, right? MySQL, Postgres, Oracle, Microsoft SQL Server, and relational databases are wonderful. I am a huge fan. It's in many ways old technology to a lot of people, but it is so powerful and very rich, right? It's hard to find a technology in the database world that is going to give you better, richer feature set than a relational database. Rich query support, high performance relational modeling, sophisticated transaction capabilities. And you can run relational databases inside EC2 instances, self-provisioned, self-managed if you'd like, but probably best to use Amazon RDS, which is a fully managed service. You don't have to worry about installing the database, upgrading the database. It's all managed for you on top of EC2. Highly recommend. And you'll have to actually optimize the EC2 instance itself if you're going to be doing it yourself, and that adds a whole lot of extra work. And because relational databases can require a lot of tuning, I definitely also advise RDS because they do a lot of that tuning on the back end. But what they don't do for you is the schema-specific kind of activities. This does require you to really consider things like indexing, views, functions, stored procedures and things like that. So for read-heavy workloads, you should consider creating read replicas. It's a great way to distribute load. RDS can do this for you and manage it for you. And there are SSD-backed storage options, provisioned IOPS, things like that as well. In addition to the traditional database engines supported by Aurora RDS, or Amazon RDS, you can use Aurora. Aurora is a cloud-native, built for AWS infrastructure database engine that provides compatibility with MySQL and Postgres, and it provides great performance, very big performance gains over kind of the standard open source versions, and it gives you a lot of freedom from licensing constraints as well. And there's actually just went GA is Aurora Serverless, which is a very cool service that instead of having a kind of a 24/7 running RDS instance, you get kind of a serverless view, and you essentially treat it like a managed service where you just get an endpoint and you interact with that endpoint, and it acts like MySQL, acts like Postgres, and you only pay for the execution time of your query. So really cool and useful service. I think this is kind of the next generation of relational databases for the cloud. Okay, so relational databases have served us well, but there are use cases that NoSQL is actually a really useful pattern. And a lot of that has to do with massive scale workloads and workloads that have less structured, maybe even non-relational data, right? If you have relational data, honestly, relational databases are really the best way to go. But if you have unstructured data or less structured data, NoSQL databases can really help you with performance and a lot of other capabilities. Their query languages and capabilities are less capable than RDBMS solutions, which pushes a lot more complexity up into the application layer. So you have to be comfortable with that. You can deploy NoSQL solutions like Cassandra or MongoDB on top of EC2 and manage them yourself. Or you can use Amazon Dynamodb, which is Amazon's fully managed NoSQL database. It's really designed for low latency and high performance at pretty much any scale. AWS uses it themselves for Amazon.com, and it scales up and down automatically for you. It also offers some interesting features like the DAX DynamoDB accelerator. It's essentially a distributed cache tier for performance. And you can also employ things like indexes and partition keys, attribute projection, and so on to optimize your performance on Dynamo. So Dynamo is a pretty cool service. For application workloads, the combination of relational databases and NoSQL databases are great, right? Generally speaking, that's going to solve most of your use cases, but they're generally speaking a bit too limited for large-scale analytics, which is becoming increasingly important in the world of so much richness of data, right? A lot of our customers come to us and say, hey, I've been storing all this data. I know there's insights there. How do I access those insights? Well, that's what data warehouse platforms are really designed for. They're designed for digging in deep into structured data, much better solution for you than a relational NoSQL database. You can, again, self-host Microsoft or Pivotal or Oracle kind of data warehousing solutions on EC2, but Amazon Redshift is kind of best of breed, and it's a fully managed data warehouse solution, petabyte scale, and you can control the number of nodes in your data warehouse. You can use dense compute nodes for high performance, and you can tune selection of things like sort keys, distribution keys, column encodings. And the other really cool thing is if you have your data stored in S3, you can turn that into a data lake and actually use Amazon Redshift Spectrum or Amazon Athena. And both of those services essentially let you perform deep analytics on structured data inside of S3, which is a very inexpensive place to store data, easy to get data into. Athena is actually a fully managed Presto service. So if you're familiar with Presto, that's what it's all about. And it's integrated with Amazon Glue, which is kind of a data catalog service. So we're covering a lot of ground. Thank you for being attentive. So let's talk about the last kind of category here in the selection process for databases, which is data searching and indexing. So this is for things like indexing content and making it searchable. So you can use Apache Lucene or Elasticsearch, index documents at scale, make them searchable and available to platforms like Kibana. And you can deploy those to EC2 instances, but hey, surprise, Amazon has a fully managed service, the Amazon Elasticsearch service, or Amazon ES, which is fully managed and it has powerful built-in scaling features that are easy to control and automate. So there you go, that's the last in that category. So let's quickly see how many of you are using each of these different types of databases. Let's see if we can get full participation in this poll. All right, look at this. I didn't ask about data warehousing. I think, I kind of consider it slightly outside of the scope of this particular question. All right, good participation. Thank you, everyone. All right, let's go ahead and see the results. Thank you. All right, look at that. 80% of you are using relational databases. That matches my expectations completely. NoSQL is actually a little bit higher than I thought at 54%. A lot of you are doing data indexing and search as well, which is very cool. I'd be curious to know how many of you are self-managing versus using the managed services. So maybe I'll do that another poll question another time. Future webinar. All right, so we've talked about compute, we've talked about database. Two more sections, and we've talked about storage. So one more section in the selection section here, which is network. And networking in AWS is completely virtualized, right? So there are product features, there are networking features, and you can tune them all to match your use cases. You can take that same data-driven approach you took for all of the other selection processes you've gone through. So let's look at location, product features, and networking features. Those are kind of the three things to consider here. So latency is driven in large part by the speed of light, and you can't beat it. You can't control it. So choose a region, an AWS region, close to your end users, right? Or multiple regions if you're globally distributed. That will make sure that your users have a better experience. But you also need to consider data locality, right? So if you have a single source of truth database that's maybe hosted in US East, but you have a customer base that also is present in Europe, you may want to create some read replicas or even a multi-master setup, kind of spanning regions. So consider that, right? Because transferring data over long distances, again, speed of light is an issue. Another way to reduce latency is to take advantage of AWS Cloud's network of edge locations, right? So there are multiple regions globally, but there are a lot more edge locations where you can use CloudFront. It's a global CDN, accelerates delivery of both static and dynamic content that you can deliver from the edge locations. And a lot of people don't realize you can actually use CloudFront to accelerate even dynamic things like APIs. In addition, Route 53, which is AWS's distributed, highly available cloud DNS service, is also built on top of the edge locations. And you can do things like directing customers to the region that is most likely to give them the best performance using kind of latency-based routing. EC2 actually has a feature called placement groups. You can logically group instances together inside of an availability zone into a placement group. And when instances are grouped together in that way, you can take advantage of low latency, high speed, 20 gigabit per second networking, right? And that's really useful for applications that are sensitive to network latency or jitter and require high network throughput. So that's a little bit about location. In addition, there are some product features you should consider. S3 has a really cool feature called content acceleration, and that essentially lets you accelerate getting content into AWS, into S3, by allowing people to upload S3 content directly at the edge. And then AWS does the work of moving it from the edge into S3 proper. And EC2 instances also have access to enhanced networking using a network device virtualization technology called SRIOV. So that's a really great feature. There's also Amazon Elastic network adapters, and those deliver that 20 gigabit per second network capacity to instances in that placement group. And then there are also EBS optimized instances, which are optimized and have dedicated capacity for EBS, right? So you can get better performance there. Some networking features of AWS products. The last thing is actual just raw like network features themselves. So these are based exclusively on low-level networking. So latency-based routing in Route 53, which I mentioned before, that essentially uses the latency of the kind of connectivity to the DNS servers to determine where to send a customer's connectivity, right? So this is routing a customer to a particular region to ensure they're going to get the best experience. AWS Direct Connect offers dedicated connectivity into AWS data centers at speeds up to 10 gig. So that's a really useful kind of service. And Amazon VPC endpoints eliminate the need for internet gateways or NAT instances. And there's application load balancing, network load balancing, a lot of networking based features as well. So that's networking to consider. All right, so the next focus is about review. And the one constant in technology is change. And AWS Cloud is perhaps the best example of this principle as they are evolving at an accelerating pace. So in addition to the environment changes to consider, your applications and the usage will evolve as well. You need to have a continuous performance review process in place to ensure that all those selections you've just made across compute, network, database, and storage are up to date and are correct still. So AWS outlines this approach where you use infrastructure as code, your deployment pipeline, well-defined metrics, and automated performance testing with load generation and performance visibility and visualization to go through that review process. There's a lot of information in the white paper on this, and we don't have a lot of time, but suffice it to say that the idea is really all about surfacing as much insight and continuous information as possible. So one of the important components of review is benchmarking. Benchmarking is where you use synthetic tests to collect data on the performance of your system and its components to kind of drive improvement. And benchmarking is different than load testing, right? Benchmarking is lighter weight. You can perform it on individual components. You can perform it at the start of a project and before you have a complete system to load test. So follow that performance review process, right? Using your custom benchmarks or industry standard tests like TPC-DS. And there's some best practices when benchmarking. So the first is to pre-warm your environment to make sure you're getting accurate results. The second is to make sure you run your tests more than once so that you can smooth out variance. And benchmarks are also really useful for evaluating changes to a component of a service to see if that proposed change will actually have a positive desired impact. So that's benchmarking. Load testing, on the other hand, focuses on your actual workload, okay? So it gives you a holistic view of performance in production. So you should use scrub data, right? Either scrub production data or synthetic data. And you should create scripted user interactions, right? User journeys that are representative of what your customers actually do. One best practice is actually to build kind of use cases in through your user stories and put in performance kind of characteristics on those user stories, and then automating those with scripting to kind of test on a continuous basis. And another best practice is to use spot instances to generate your load when you're doing your load testing. That'll reduce your cost. And you should make sure your load testing actually reflects the geographic distribution of your actual user base. So make sure to test at scale from the places that your users are actually going to be. So let's find out if you're doing benchmarking or load testing, or both or neither. Very interesting. So in my experience, a lot of companies do load testing because it's a holistic view and it's something that you do at the end, right? People rarely do benchmarking where they're testing the components as they build up. And I will say, benchmarking, I think, is a really valuable thing to implement in your business because it can accelerate your ability to get better performance. If you wait until the end, it's harder to track down what's going on if you're just looking at the holistic system. Okay, let's go ahead and close the poll. Great participation on this one. And as I suspected, a small percentage of you are doing benchmarking, more are doing load testing, but and actually a good chunk of you are doing both, which is really encouraging. Neither 26%. So I think those of you, I think a great place to start is benchmarking, right? Pick a component and start there. Okay, still have some ground to cover here, so not much time left in our slot here. So the next focus area is monitoring. So you've implemented your architecture, you've picked the right resources, you have a review process in place. Now you want to implement monitoring to actually ensure that is continuously improving. So there's two complementary types of monitoring to consider: active and passive. Active is simulated user activity in a continuous fashion to test performance and availability. You can run it in all of your environments from development staging to production, and it can help identify issues before they impact customers. Passive monitoring is actual user activity monitoring, right? Really useful for things like user segmentation, geographies, user subsets, browser subsets, and other things. It's particularly useful for measuring things like user experience performance, geographic variability, and the impact of API use. AWS divides monitoring into 5 phases: generation, aggregation, real-time alarming and processing, storage, and analytics. And that is the process of essentially defining your metrics and thresholds, collecting that data and combining it, and then actioning on it, right, alerting, storing it over a period of time so you can surface insights and build out analytics reports and dashboards. The critical service you really need to know about for this is CloudWatch. So it enables all 5 phases of monitoring, and it can collect and track metrics, not only for all AWS services and resources, but also for custom metrics, including log files. So very useful. Next is trade-offs. This is the last kind of focus area to cover. And in my introductory computer science courses, I remember my professors always talking about everything comes down to the trade-off of space versus time. And it's really quite true. If you actually look at this table, you can see 4 trade-offs that are kind of exemplar trade-offs that AWS kind of points out that you can make to help you meet your goals. So we'll go through each of these, but this is a nice little summary. You can see the trade-offs themselves. So let's start with caching. Caching is the notion of trading space, right, which is duplicate data, for time, performance. And that involves, so the use case here is a database, right? You have a relational database potentially that's your single source of truth. As you scale up, that can become a bottleneck. Caching, you create read replicas, copies that take more space, but they accelerate your performance, right? There are app level caches, database level caches, and geographic caches. App level involves changes to your application code. You can use things like Elasticache, Redis, Memcache, Varnish to essentially use memoization techniques inside your application. If you don't want to have any application level changes, you can use database level caches, which I mentioned before. Read replicas, big benefit there is you don't have to really change your application that much. You can essentially load balance it. Geographic caching is essentially CloudFront, right? Using CDNs, trading space for time, replicating content at the edge. And you can use it for API acceleration and for dynamic content as well. So that's caching. Partitioning or sharding. So this is when your database grows so large that you can't vertically scale it anymore. You have to start splitting that database up into multiple databases, and that's called sharding. You essentially take your data and you segment it by a partition key, and you deploy several distinct databases that all together contain all of your data. This is a very complex thing to do. and it involves a lot of application code changes. And generally speaking, I would say if you can avoid it, I would. But if you have massive scale, you're going to need to do it. NoSQL databases have an advantage here because they're essentially built on distributed systems, and they use horizontal scaling techniques to kind of transparently do this to the application. So much easier. Now let's talk about compression. So this is where you have space being a concern. You can trade off CPU, compute, time for space, right? And this is built into most AWS services. So the final trade-off to consider is buffering. We really covered this in the cost op pillar, but the notion is that you can separate the production of messages and work from the consumption of messages and work by queuing it through Amazon SQS or Amazon Kinesis, and then reading off of those buffers to kind of create more efficiency. So if you want more detail on this, I'd recommend watching the webinar on the cost optimization pillar. So real quickly, last question. Based upon all this data we went over today, a lot of dense information, do you feel your company would benefit from a well-architected review? So my view on this is every company can benefit from a well-architected review. And as I mentioned, we have a handout attached to this webinar. Please do download it and please take a look. It is a very, very good program. It's free. You set up a consultation with us, you get a well-architected review with some experts who are really trained in all of this information and much deeper than we're able to cover in an hour-long webinar. And you get $5,000 of credit on your AWS bill, and you get $5,000 worth of work out of us. So it's a pretty great program at no cost to you. So let's see the results here. And look at that. 62% of you are on board for getting well-architected reviews. So what I'm going to ask you to do is download that webinar or download that handout. And go ahead and ask us for one. We'd love to help you out. For the 21% of you who say no, it's totally cool, I get it. The 18% of you who are still curious, still download the handout, learn a little bit more. All right, so covered a lot of ground today. I'm not gonna even bother summarizing. I wanna get right into Q&A. We only really have a minute left for Q&A, but I'm gonna extend the webinar by about 5 minutes to give us a little bit more time. Thank you all for the questions. I'm gonna take a look at them real quick. So the first question was, will the deck be available after the meeting? Yes, the deck and the recording will be available about 24 hours after the webinar. We'll email you. Let's see. May I get a link to the cost optimization webinar? Absolutely. If you actually look in the question and answer section, there will be a link to the previous webinars. Let's see here. Someone here is saying that they are having problems with Amazon Aurora tuning. Yet there are lots of tuning techniques out there. Brian actually gave some good recommendations here around gathering performance metrics for your application. We can definitely help with that if that's the type of thing that you want some kind of professional extra eyes on. We have solutions architects who are experts with Aurora who can really take a look at making that better for you. Heuristics and baseline for data-driven approach for deriving CPU, memory, and storage options. I think the answer to that question is yes, but it really does depend on your application, right? And this is what Brian was saying. Only you know how your application performs. I think there are some kind of exemplar use cases. So for things like a WordPress website, we've got a lot of experience running those workloads. We can give advice specifically on the types of instances that you should use, the type of behaviors you'll see. So I think it really does depend on the application, but there are heuristics. It just is based on the application itself. So Matthew Savino has a great question here for Lambda cold start timeouts and ping hacks to keep them alive. So Lambda, because you don't control the execution environment, sometimes your Lambda environment will be spun down to save money, basically. Amazon will spin it down because it's not been accessed in a while. So there are ways that you can do things like creating a no-op that keeps your function alive to prevent cold starts. I do this all the time. So it's a great question. there are some great frameworks out there that are emerging for building serverless applications on top. There's one directly from AWS called Chalice. There's something called the Serverless Framework that's great for a variety of different applications, mostly Node.js applications, but works on everything. The third one out there is called Zappa, which is one that I'm a big fan of. I use it myself. It's a Python-based framework. All of them have built-in capability to toggle on, essentially, keep alive, keep my function warm, right? So it's definitely a thing you can do. Can you use New Relic monitoring for Aurora? The answer is yes. And is New Relic free? No, there is a free trial you can get. If you are interested in application performance monitoring, this is actually something that we have a ton of experience with. We offer a really great service for advanced APM that we provide to our customers, where essentially we deploy New Relic APM across your entire fleet or the segment of your fleet that you want. We monitor it, we put in alerts around it, we give you insight about where your hotspots are and help you tune your application. It's a really great service, highly recommend. Let's see. Where are other parts of these sessions, as this is part 5? We have links. We will send links by mail, good question. And Matthew had a follow-up questions. The 3 serverless frameworks are Chalice, Zappa, and the Serverless Framework, which is at serverless.com, I believe. All right, so we got through all the questions. Thank you so much for joining us today. This has been a real pleasure to deliver these 5 webinars. Again, go back and watch the others if you haven't had a chance yet. Please do reach out and get in touch about getting a well-architected review. We'd love to help customers really be successful on top of AWS. It's kind of our favorite thing to do, is to help you be successful. So feel free to reach out. I'm also available to, as the CTO, to consult with you if you want to have me come on site or engage with your team. We'd love to do that as well. So thanks again, really appreciate it. Look forward to all of the well-architected review requests. Have a good rest of your day.